Good, good afternoon, sir. कैसे हैं सर?
बस बढ़िया है, doing fine.
Okay. So we have actually participants more than 100, but till now only 38 have joined. So we can wait for another 5 minutes so that the other can join.
बिल्कुल. That's
Okay, sir. Okay.
link भेजे तो इधर
So sir, can we start now? Sir, your voice is, I think, mic is off.
Yeah, we can start.
Yes, sir. So, good afternoon, all participants. Good afternoon, Dr. Emmanuel Pillai, expert for this session. So, before we start, I would like to introduce you the brief introduction or brief profile of Dr. Emmanuel Pillai. So, Emmanuel Pillai Shubhankar has 24 years of teaching, research, and administrative experience. He was awarded PhD from Indian Institute of Technology, Roorkee, for the thesis on a framework for network forensic analysis in 2012. He completed a research project investigating the sources of spoofed emails from UCOST, Dehradun, in 2016. He has co-authored a book, Fundamentals of Network Forensics, a research perspective for Springer in 2016, and Cloud Security Attacks and Techniques, Tools and Challenges for CRC Press, Taylor and Francis in 2021. He has supervised 8 PhD theses and 38 MTech dissertation. He is presently guiding 3 MTech and 6 PhD students in security and forensics, cloud computing, big data, IoT, quantum computing, and blockchain. He is the Associate Dean Research. He is an Honorary Dean Network and Hardware in Rajasthan ILD Skill University, Jaipur. He is senior member of both IEEE and ACM. He is member of Cloud Computing Innovation Council of India, CCICI, Quantum Ecosystem Technology Council of India, and Digital Forensics Research Workshop. So, sir, on behalf of the Department of Computer Science and Engineering and the organizing team of this course, I welcome you here in this session. So, over to you, sir, for this.
Thank you, Dr. Krishnapal Sharma, and it's a joy to meet you again, and also all the participants here. It's a joy that we are here to speak about. Today, we'll be discussing about security and privacy issues of blockchain. Blockchain, when we hear in India, it's more of commercial interest. We would like to buy and sell bitcoins or any other cryptocurrencies. Many of my friends or people who are working on blockchain research, there are so many queries that people ask. Not technical, but actually about what is the cost, what is the prediction, what will be the rate, and all. So most of the time, I explain the technology and I say that this is what it is. But then you better look at the other websites which give that kind of information about the finance part of it. So let us try to look at it, because one of the important things that I try to include this as part of any cybersecurity workshop. Whenever they ask me what do you want to speak, I would suggest. Of course, I would like to introduce blockchain, and then also there are issues again on security and privacy issues in blockchain. But what I would like to highlight here for the first half of the lecture would be to actually tell you about what are the some of the concepts which we use, which are purely which we learn and teach in security, right? Like hashing, public key, private key, PKI. The key exchange, and a lot of these things, and then of course elliptic cryptography, and some of these things which are the heart of the blockchain concept as such, right? I will take you through some demos which are available online. You can also use that and look at that sometime later. Of course, a lot of content may be appearing, but I would like you to take this talk as a talk to ignite the passion, right? So there's a vast amount of information. A lot of books are also written. One of the book I can suggest by Arvind Narayanan, right? Of course, he's an Indian, but he's abroad, and he has written a good book on Bitcoin and cryptocurrency. So I think a very standard book you can refer if you are interested to pursue Bitcoin research. Some of the challenges that I will be talking about, and when you look at Bitcoins or blockchain, when you look at it, don't look at blockchain only as a cryptocurrency medium, a medium for cryptocurrency, or a medium to generate or store and retrieve digital currency. But please look at it as a very strong trust management system, right? Very, very strong trust management system, which is built on very strong cryptographic principles. And the use is not only with cryptocurrency, but so many aspects. So that is where if we don't start using blockchain, or don't start understand the working of the blockchain, we will be left behind. There are so many things that we will be left behind if we don't really catch up. One of the things are like blockchain. The other one is mixed reality. The other one that we talk about is, the other aspect that we talk about is quantum computing, which is coming up. So some of these aspects we need to really get hands-on with. So I will encourage you to keep looking for any workshops or seminars on these topics, and we'll look at that, right? So let me start off, try to give you the first half. We'll talk about what are the concepts behind blockchain. Some of the security aspects are involved. Hence, for some of you may not have worked with blockchain, may not have heard about blockchain also. So, and hence, I will keep the common denominator. Kindly excuse those who have already worked on blockchain or have been implementing something on blockchain. Kindly excuse me. For some part of the time, I will be delving on what actually or how actually is the blockchain working. Then slowly we will move on to actually trying to explain what are the security aspects in blockchain. We'll also look at some of the government strategies which are going on, and also the current research that is happening. Of course, I will also briefly share some of the work that we are doing in MNIT on blockchain related to security and privacy issues, right? Few years ago, I think before pandemic, I attended a workshop in IIT Bombay, and we were talking about security and privacy. And I was at that time getting my hands-on with blockchain and trying to grapple with some of the concepts of blockchain. So most of the people smiled, and in fact, some of them laughed, and some of them made fun also, saying that it's such a strong system. Nothing can break or nothing can go wrong, or I don't see there are any security vulnerabilities that will come up in the days to come, right? But of course, I was hopeful that for me, any system that has commercial value, any system that that actually generates money or involves money, right, it will definitely be attacked. And as of now, when the system is designed or when the system is developed, you may feel it is foolproof. Like when the blockchain started working a couple of years ago, 2009 it started, but 2000, maybe like 2020 and 2018, at that time, we see that there's a huge demand. In fact, most of us Indians would have heard about Bitcoins when we heard about the virus called WannaCry, right? The WannaCry virus encrypted systems. Of course, a lot of variants are coming. Recently in our institute, one or two systems were encrypted like that. So you can try to understand what is the challenge that is there. At that time, people said if you want to get the systems decrypted, the person who encrypted sent a message and asked to contact and pay the money or on some channel called Bitcoins, right? You pay in Bitcoins. So then people started finding out where to buy the Bitcoins, how to buy the Bitcoins, and then sell, then try to send the money so that they could retrieve their data, right? Even such attacks are happening even now. People will still ask some kind of Bitcoin currency or some other mechanism for them to transfer the money, right? So that is what we'll try to understand. That's where we first heard maybe 3-4 years ago. But then we have come a long way, and India has, we are not aware, mostly in the academic community, we are not aware of what's going on. But you may ask some of your students, they will be trading in Bitcoin, they will have a Bitcoin wallet, they will have, like how we have Paytm wallet or PhonePe wallet, we are very happy, we have so many wallets, right? Google Pay and all. There are so many other wallets on Bitcoins also, which the students create. Of course, many of my students also give me more information than what I have, because we are not, I'm at least not commercially inclined towards Bitcoin. I'm only technically inclined. So I will usually look at some research papers, but I'm not actually following it as a business model, right? Trying to invest money and do that. So, but you can do both. That's a challenging thing because it's like a stock market only. The rate goes up and down. You will see that in a couple of minutes from now, right? So this is the kind of basic introduction that I would like to start with, and then let me share my screen. And of course, I will share the slides. Please don't worry about it. And some of the papers also I will share, and we are coming to that. So let me just look at that. Yeah, are you able to see my screen? Hello?
Haji, yes, sir. Sorry, it is visible.
Screen is visible. So yeah, so we'll look at this thing. So when you look at Bitcoin, these are the words that you will try to remember, right? So some of the words that you can see. So when did the genesis of blockchain start? The first blockchain, which is usually the Bitcoin blockchain. So it started somewhere in 2009 January, right? As you see it on the screen. So this was the first block which was created of the blockchain, right? So this was block number 0, and whenever the system was created in such a way, that whenever a block is added, you will get reward, right? So there was 50 Bitcoins were rewarded whenever a block is added. Right? So we look at what is the logic of how to add a block and all that, right? So Times of London came up with a write-up saying that Chancellor bailing out banks. Okay, Chancellor bailing out banks. So what was the understanding here was Bitcoin was not charging any transaction fee in the initial. The basic idea why the Bitcoin concept came into picture is whenever I want to transfer money from one country to one place to other place, banks usually charge a transaction fee, what do you call the DD rate, or bank transaction charges that you had. Now, if you send some 10,000 rupees, you are charged some 150 rupees or something by the bank, right? Depending on the amount, as the amount increases, the transaction fee also may increase. So these are kind of, so the blockchain wanted to actually start off with no transaction fee initially, and then slowly, as we see now, it is added as the transaction fee is also getting added, but it is very minimal in the sense, but there's a slight amount of this thing. But when it started, they wanted to do away with the transaction fee. So they wanted to create an alternate banking system. You try to understand. Maybe what do you say? The whenever I want to send money to anybody or receive money from somebody, I would not need to pay any transaction, or maybe may pay very less transaction fee compared to what actually happens when somebody is sending money from US to India. Let us say huge amount of money he has to shell out to send the transaction. If he's sending some $1,000, almost like something like $100 he has to pay. But using bitcoins, you can transfer even a huge amount of money with very less transaction fee compared to the cost. So that was the basic intention. So what exactly is a blockchain? If you look at it, started with this paper. It was like a paper which was published and let free on the internet, right? It was a Bitcoin white paper. So peer-to-peer electronic cash system. So it was proposed by a person called Satoshi Nakamoto. We don't know whether Satoshi is a live gentleman or not, or who he is. Maybe male or female also, we don't know. But then it is named by that, and there's an email there, and the organization name is also there. But we actually don't know who he or she is, right? So we don't know whether there is an individual. So till today, who is behind the Bitcoin or blockchain concept? Nobody is fully aware, right? So he let it go, and then later he created. After 3-4 months later, he created the first block that we discussed here. This block was created, right? So if you want to try to access bitcoins, I want to get a bitcoin, right? There are 3 ways as of now. First one is you can buy it from a Bitcoin exchange, right? I will just explain a little later what are those Bitcoin exchanges, right? So you can use your fiat currency, that is your rupees. If you're in US, you can use dollars. You are in some other country, you can Japan, you can use your yen. And then you can buy bitcoins. Second one, if your friend has a bitcoin, then you can transfer it to your address, right? So your friend will have an address, and you can have an address, and then we can transfer the amount to the bitcoin address, right? Secondly, lastly, you can also mine a new block. This is something which is spectacular, but of course now you need a huge, what you call hash power. It's called the hashing rate, right? Maybe you have written programs on cryptography for hash functions, maybe SHA, some functions you would have written. So here we are talking about a power which is able to create or test 276 million terahashes, not a single hash, terahashes, and not a single terahash, 276 million terahashes per second. So that's the kind of computational power which is required to ensure that speaker mute. आपका speaker, outgoing speaker mute कर. Yeah, sorry for the mistake. So mine a new Bitcoin. So Bitcoin current hash rate 276 million terahashes. So that's the kind of thing. So what you do, if you have this power, you can add a new block, right? You can solve a cryptographic function. We'll discuss it shortly. So then you can add a new block. Then obviously you earn bitcoins as a reward, right? So that's what we look at, right? So hash rate is basically a measure of how many times the Bitcoin network can attempt to solve the proof of work puzzle. If you want to add a block, you have to solve a cryptographic puzzle. The cryptographic puzzle is called POW, or proof of work. Now you have a variety of puzzles. Proof of stake is there, and similarly there are different mining algorithms which have come up, right? So we will hear about that also slowly as we move on. The more hashing power in the network, the greater its security and overall resistance to a 51% attack. We will see what is that 51% attack also, right? So the Bitcoin current hash rate is 276 million terahashes per second. So this is what exactly is how it proceeds. So that's about the hash rate that I talked about, right? So now, how does a ledger, or what is a blockchain? Blockchain is a public ledger. Now, what is a public ledger? What is a ledger? If you remember, maybe now you have not seen ledgers, but when I used to do our transactions on the passbook and all, now you don't know what is a passbook. Also, some of you may not have seen what is a passbook. You only know a bank statement. Now, the bank statement is nothing but a ledger, right? So, Bitcoin, the blockchain is a public ledger. So the public ledger is anybody can see all the transactions. So now maybe if I say that you have a bank account and that bank account can be seen by everybody, then you will be very much alarmed. What is the use of blockchain, sir? Then when everybody is able to see all the transactions, yes. If I tell you everybody can see all the transactions, but nobody knows whose transactions they are, then you will be happy to understand that, okay, then there's no problem, right? So that is how you will try to do that, right? In that case, what will happen is when you have these the Bitcoin ledger that you create, it shows all the transactions that are happening in the whole system, no problem. But then nobody knows whose transaction is what is happening. So here, this ledger is a kind of every block will have this statement, right? So here is the block number that you can look at. This is a previous slot. Maybe this was something in 2020. I've taken a snapshot. I will show you the latest list now. This is the block. When I took the pic, this was the number, and these are the number of transactions in that block. And each transaction is actually talking about one transfer of money from one person to another person, right? So, and then the transaction fee that is related to that, and the the transaction fee that is allocated, and the amount, the reward now is 6.25 bitcoins. Now, earlier it was 50 bitcoins. It slowly become half. It came to 6.25 bitcoins. The timestamp is all. So this is what is available in any blockchain. So you can see that on blockchain.info or blockexplorer.com. These are front-end interfaces to the blockchain. So blockchain is running. It's a peer-to-peer network. It is maintained. Nobody is centralized. Maintenance is not there. But of course, it is running on a strong cryptographic program. And though people are not maintaining it on a second to second or a transaction to transaction basis, but overall people are monitoring and controlling the blockchain, how it is proceeding. So that's what I can say, right? So there is an inbuilt program which is running, which is peer-to-peer network. So when I want to join a blockchain, I can also create a node and join a blockchain, and I can also become a part of that. Then I can become a miner and I can mine the blocks. So whenever I maybe the first step, if you ask me what should we do if you want to do research on blockchain, so please set up a private blockchain so that you can understand or try to set up a node and connect to a public blockchain. Both these things are possible. So what you can say, a permissioned blockchain and a permissionless blockchain. Permissionless blockchain is usually the public blockchain like Bitcoin or Ethereum. There are so many names that we have. So you can connect to the blockchain, right? So that's the first level. You can try to create a node for Bitcoin blockchain. If you want to join, there is a Bitcoin core, the software. You can download that software and set up a node. And once you set up a node, you can connect to the blockchain. And once you connect to the blockchain, you can download all the transactions that have happened till date. Right? Based on those transactions, you can try to look at what are the future transactions that are to be made. So you can get the entire database. Now, here I would like to also share something to some people who are mostly into what is called the data science or the machine learning group. Some of you may be here and you must be listening. What can we do with machine learning? I want to do only with machine learning. Now, here is one good opportunity. There's a huge lot of data. So many transactions, a few millions of transactions are there. That data is readily available to you. You can download it, and then you can run some of your algorithms on that and try to find out some aspects. So a lot of privacy issues and security issues could be find out. We will come to that also. But then this data set is readily available. You can download it, and it's a legitimate data set. Everybody has a copy of this. Every peer in the blockchain network will have a copy of this entire database. So this is how the data set looks like, right? So yeah, and yeah, this is the present. This is the latest pic now, which was created. So you can look at that. This is the height of the blockchain that is there presently. And then you are able to see that, right? So that is how this proceeds, right? So these are the that is a hash of the block. When it was created. So you can see that in 1 minute, usually about 6 blocks are created. So usually about 10 minutes, every block is created. In 1 hour, 6 blocks are created. That is every 10 minutes. You can roughly every 10 minutes. So if you see here, this 2 hours, you see, so that is that proceeds like that, right? So now this is how a block looks like, a single block, right? What is a single block? Single block will have an address, right? The block will have not an address, it will have a block hash, right? So this is how a block is identified. The block will have a number. This is the height. Again, this was an old example that you can look at. The timestamp is also given somewhere here. Yeah, timestamp is here. This is 2020 block. So a recent block could also be added, but of course the slides were there, so we are using that that example I took. Okay, so here is where you have there's a block address which is having 19 zeros which are preceding, right? So these 19 preceding zeros are placed in the block hash. So whenever I want to add a block, right, when I want to do mining, now you have to add a block. If I want to add a block, I told you I have to solve a cryptographic puzzle. Now at the result of the cryptographic puzzle is this hash value. This hash value has to be generated, and this hash value has to have 19 or 20 preceding zeros depending on the difficulty level, right? Difficulty of block mining. I'll come to this difficulty level, I will explain. So this block values, this 19, usually 19 or some number of zeros, preceding zeros will be there, and that will be the hash value which you have to create, right? Now the hash value will be depending on inputs. What are the inputs? So it depends on all the transactions that are there in this. Like the transaction count here is 604, right? So all the transactions, they are created into a data structure called Merkle tree. I will briefly explain what is Merkle tree in the coming slides, but you can refer to any data structure book and try to understand what's a Merkle tree. Merkle tree will create the hash of every value, and it will create a tree. So the Merkle tree root is one input to that algorithm. The second input is basically the previous hash, previous block hash. So this is the present block hash. Maybe here you see 073. So 072's hash value, that is a previous hash value here. So this is another input. And the third input is the nonce, these three values. These three values are used to create a new hash of the next block. So this hash must be less than a certain value. Till you create that, you have to keep on checking the hash values. You have to keep on changing the nonce value, because these two are fixed. Merkle root is fixed. The previous hash value is fixed. Only the nonce can be changed. So a brute force kind of an algorithm has to work to generate this hash value. So many hashes have to be generated in 1 second, so that in about 10 minutes time, you will be able to find out one block's address. So I am really amazed at the way that this gentleman has created this whole system, and he is running it. So that is how I feel it's exciting in the sense of this use, right? So that is where we can try to look at. So the cryptography behind it, right? So the address that is, the value that is generated, the addresses that are there, all these things are all cryptographically inclined. So we'll look at that, right? So that is how you can look at, right? So when you add a block, so you will have to calculate the previous based on the previous hash value, based on the transactions, you will create the Merkle tree, and the Merkle root value you will take, and you look for different nonce values. And once this nonce is set up, this value comes up, then you are ready to add a block. Now there's so many people who want to add blocks because they're going to get six bitcoins, 6.25 bitcoins. So there's a huge competition that is going on, and whoever adds the block first gets the money. What will the others who will do it? What do? They will go for the next block immediately, right? That's one thing. But while the next block's program is running, they will go and update this value also. They will update. They will verify other miners whether they have done it correctly or not. So their miner has two objectives. One is to add a block. The second one is to actually get to verify the other blocks. So two jobs he does. Second one is voluntary. You don't want to verify others, you can go on and try to find out. But then people do that because tomorrow you also expect somebody to verify your blocks, right? Otherwise, nobody will verify your blocks. So that is something that you can look at, right? So this is how a ledger looks like, or the transaction looks like, right? So this is the transaction hash, and these are the addresses. Okay, so usually the Bitcoin address are of 35 characters. Okay, so 35 characters represent an address. So you have your, whenever you create your what do you say, a wallet you are aware of, because you know what is Paytm wallet or PhonePe wallet or Google Pay wallet. Similarly, you can have different kinds of Bitcoin wallets. You can have wallets where you can deal with all kinds of blockchains as well. Different cryptocurrencies can be exchanged and manipulated also on a what do you say, and a wallet which is issued by different exchanges. You can use that. That is one part. Or you can go and create your own wallet, or create your own this address can be generated. But so this address is depending on a public and private keys, two keys. Whenever you are setting up a node, you have a private key and public key which is available to you. It's like your password. So using that, you can create multiple addresses. You don't have to use the same address always. You can, using those keys, you can generate different aliases, that we call it, different kinds of addresses which are there. So these addresses will transact this money and send it to different addresses. So you can use multiple addresses and send multiple values, and you can send the result to that. So there's some transaction fee also that is involved. So this will be the things that is there. So these are the input transactions, and these are the output transactions, and the amount sent and amount received plus the transaction fee will match for every block, for every transaction, in fact. So this reward initially was 50 Bitcoins when Satoshi started, but then in 2012 it became 25 Bitcoins. There's an automatic mechanism, roughly 4 years they are changing. So again, July 2016 it became 12.5, May 2020 it became 6.25. Hopefully in May 2024, before May 2024, it will become 3.125 Bitcoins. Anyway, they have some mechanisms, they are halving the Bitcoin rewards, right? So as of recently, this is sometime where there was a peak of Bitcoin cost. So November 2021, 49 lakhs, roughly, and then it moved on to become on 10th November, it also becomes 67 lakhs, right? 67 lakhs for one Bitcoin, right? Now it has come down to 17 lakhs, today's value, right? Today's value is 17 lakhs. So just imagine somebody has purchased with 67 lakhs. Today his Bitcoin cost is 17 lakhs. He has lost 50 lakh rupees. Okay, that's a loss. But somebody would have purchased in 17 lakhs at one point of time, and suddenly it became 67 lakhs. At that time, he would have sold. He would have earned 50 lakhs straight within less than a year. So this is like a stock market. So please be careful while you're dealing with this, right? So anyway, that is how a present trend is. And then a lot of people are accepting now Bitcoin. So as you see, PayPal, you can, it is almost accepting Bitcoins as a legal tender. Of course, as of now, India is not yet accepted Bitcoin as a legal tender. What is a legal tender? If you know, today a 2,000 rupee note is a legal tender, a 500 rupee note is a legal tender, but a 1,000 rupee note is an illegal tender, right? So Bitcoin is not illegal, yet Bitcoin is not legal. If Bitcoin is legal, so government will give you a backup. The Reserve Bank of India will give you a backup, because if your 2,000 rupee note is torn today, if it is torn, then what can you do? You can go to the RBI and get back another new note, right? But in case of Bitcoin, government is not able to give that kind of backing. So in India, though it is not legal, though it is not illegal, it is also not legal to have transactions on Bitcoin. But then, yeah, you are not doing anything wrong if you buy and sell Bitcoins. So that's what I would leave it there, right? Then apart from Bitcoins, there are so many coins which have come in, like Litecoin, like Ripple, like Dash, Monero, Ethereum Classic, and so many. The dots one I'm not able to look at, but anyway, you can look at on the website, you'll be able to get it. So these are the names: Bitcoin, Litecoin, Ripple. This is Ethereum Classic. This is Dash. This is Monero. So you can look at that, right? So the variety of Bitcoins which have come, alternatives to these. So here also, these are the top 10 Bitcoins, crypto coins in the market. So you can go to any website, you will get this. So I'm just not delving on it, but I'm just making it that there are so many cryptocurrencies, so many blockchain concepts that are in the market, right? So why does a Bitcoin matter for us? Is because it's a cryptocurrency which is purely digital. That is one aspect of it. But then it is not controlled by any central entity. There is no federal bank. There is no reserve bank behind this. thing. There is no central agency which is controlling the currency. So there is a big risk. What is a big risk? Someday, if the software fails, no, and you have invested a lot of money, the money is at your risk, right? Nobody can help you try to recover the money. That's a big risk. But then the computer science behind it, the cryptography behind it, has given people the confidence that this will not not go bankrupt, or no kind of it will not stop, because so many people's money is involved. Everybody wants to keep it running. Nobody wants to see that it fails. So why blockchain is having security attacks is because a lot of money is involved. Why it is still able to face the security attacks? Because people don't want it to go down. If it goes down, a lot of people will lose a lot of money, and hence blockchain continues to run. And blockchain doesn't make mistakes, because and hence the trust is increasing. Hence the amount rate is also increasing. That's what you can look at, right? So the peer-to-peer network in which the transactions is directly between users, there is no central agency. So it's a peer-to-peer network, right? And transactions are not verified by anybody. They are verified by the miners themselves, or the network users themselves, right? So it's like a central government. It's like a people government. The people are managing the whole thing, and the people are the people who are verifying the things also, right? And everything is recorded in a public ledger called the blockchain, and nobody can change that public ledger. What is a blockchain? If you look at it, it's a distributed ledger, and everybody holds a copy of the entire log history of transactions. Everybody who is a stakeholder who is connected to the blockchain can get a copy of the entire log history of transactions. So I cannot say that no, these are my transactions. So my transactions are not matching with your transaction. It should match with everybody else's transaction. You cannot make changes in your copy of the blockchain and say that, sir, koi galatfahmi ho gayi, mere paas itna paise hai. You cannot say that I have so much money. You cannot claim I have so many bitcoins. It should be reflected in everybody's blockchain. So that is something. Once you have written the data, the transactions have been written, you cannot change any transaction. If you change the transactions, it will become a big problem. And it is also time stamped. So some of the beautiful cryptographic principles and computer science principles are involved in building a blockchain. It's a very good system. And of course, one of the products of this is the cryptocurrency. But yes, there are so many other byproducts which are coming up. And then that's what is interesting for us. Anyway, let's move ahead, right? So I will take you through to a website called andersbrownworth.com. I will stop sharing the slides, and I'll come back to the slides. So there we will be able to just quickly understand how this thing happens, right? So let me just come back to that. Let me go back and share something else. So here we have the blockchain demo. Yeah, are you able to see the blockchain demo website? Yeah, is the website visible?
Yes, sir, it's visible.
Yeah, this is the please note down this address if you want. This is andersbrownworth.com blockchain hash. So that is something that you can look at, and I'll put it on the chat. Right? Yeah. Is my voice having a problem sometime? Somebody has written a comment. Yeah. Anyway, whenever you let me know, so that I will repeat if you have missed something, right? So here is this where we are doing a blockchain demo here. I'm showing you block by block, right? So initially, just you want to have a hash value. So if I type my name, you see that the hash value is generated. So there's a program which is there. So for every character that I remove, you see that the hash value is changing, right? So if I add also any change that happens, so that hash value changes. So just I added initially there was nothing, so this was a hash. So when I add my name, as I add one character, the whole thing changes, right? So that is how hash, and I will leave it for you to understand what is the secure hash algorithm 256. Right? So hashing is where you give an input of a text or a string or a number, and a related hash value is generated. Usually the hash value is roughly 64 characters. Okay, for this example, this may be different for the Bitcoin. this thing, it is different. But for this, he is giving a smaller example. That's all. Right, 64 is usually in the this thing, right? So this is how a block looks like, right? This is only a demo, so you can understand. So here is a block number that is given, then there's a nonce value, then some data where you can add, and here instead of the 19 zeros, I've just put 4 zeros, because if you want to create a 19 zeros, if you want to create a 19 zeros this thing, it will take a lot of terahashes that we need. So we are not using that. We are just using a sample example here of four initial 4 zeros, right? So when data is not there. So let us say I have a transaction here. A is making a transaction to, let us say, B, worth of some $100 or 100 rupees, right? So when I make this 100 rupee transaction, right? So I make this transaction. So what has happened? The hash value is not having first 4 zeros. So this is now what I have to do is I have I take what do you say, the Merkle tree construct of this transaction. I get the Merkle root, and now I have the previous. If I go to the previous hash value, but as of now, let us calculate the hash now. This value has changed, so if I calculate the hash, this is a mining algorithm is running behind this, and now it will generate first 4 zeros, and the hash nonce value has changed, right? So if I make a change here, right, if I want to make it $50 later, the color has changed. That means this is an invalid transaction because the hash value is not again first 4 zeros. Now you see the hash value here, and now when I do the mining again with this new $50 stake. So this is the nonce value. So once a block is created with this kind of a transaction, now whenever I make a change, then the hash value will change, which will be wrong, right? So that is how you can verify. Now, what is a blockchain? Blockchain will have a combination like this, a series of blocks. So the previous hash value of this block, the first block will not have any previous hash value. This is the genesis block. Let us think of. Second block will have the address of the previous hash. The previous hash is coming here. Now, if there is a transaction here, now this transaction will be copied here, and now you have to find out the transaction value. So these 3 values are used. So A is making a transaction B of, let us say, 100 rupees, right? So this transaction is being made. So you see that all these changes are done. So now what has happened? This hash value has changed. So the previous hash value, the Merkle root of this value and the nonce, when I take together and I mine it, right? And this value will change, note it here, and then you have the first 4 zeros here, right? Similarly, if you want to, again, this value has changed because the new hash is copied here. This is also being valid. So again, you have to mine. This nonce will have to change, and then you'll get the first 4 zeros. Like that, so this blockchain will be maintained, right? So if you look at the distributed blockchain, right? So here is your peer A, then peer B will have the same copy. Peer C will have the same copy. If I want to add any transaction somewhere, it has to be reflected everywhere. You may say, sir, see here I am adding this. This is like A to B. I am having 100 rupees here, right? So I have put this. So and then what I try to do is I'll mine it. I'll mine it and make it very active here. So this is 8*52, and then this is there. But then it must be verified with the others. This hash value will not match with this hash value. The hash values will be different, or nonce values will be different. For others, the nonce values will be same. So you cannot make a localized transaction change, because if you change one transaction, all the transactions subsequently are all affected, right? The next transaction also affected, right? And this will not match with the other peers. So you cannot make any transaction changes in between. That is what is immutability. And this is one principle. If I want to use a data which is fixed, for example, one of the application, you can look at the land registration data. Once the land registration is recorded, I don't want anybody to change it. Nobody can change it. And you can use the blockchain as an application. Maybe you are using your 10th class marks or 12th marks and all this, the grade sheets that are there. You want to store it there. Or maybe your vehicle registration ID or your passport or some of these data, you can put it there, like how you have an example of DigiLocker, right? So you can put your data there and retrieve at any point of time. So once it is there, it is verified for life. So that is what blockchain can be used. You can trust blockchain, because once blockchain's data is stored, you cannot make any changes in that. So that is how you can try to continue with that, right? Then you can have tokens which you can use. As I showed you the transactions I was showing, these are the different transactions which are there, and all the transactions, for that you create a Merkle tree. The Merkle root will be used, the nonce value used, the previous hash value will be used, and a new hash will be calculated, right? So when I talk about Coinbase, Coinbase is when when I create a block, I get some initial Bitcoins. So here I'm giving $100 to somebody who has created, Anders has created, so it is given. So you can watch a video also related to that. So you will understand very clearly. So this is a demo. You can go to this website and play with it. You can do anime, test it, run some. Of course, what is the mining algorithm is not given, but of course he shows how a blockchain. This is a kind of a simulation of what a blockchain is, right? So we'll go back to that. I will stop sharing here. We'll go back to the any questions here? No? Yeah. Okay. Yeah. Hopefully you are following what I'm saying. Is it clear till now? Yeah. Hopefully that is there. So let's proceed. Yeah. 1 minute. I'll share the tab. I'll share the screen. Yeah. How do we make it full screen here? Yeah, we are here. So transactions are messages that let users spend their Bitcoins, right? So you have hash value, hash of the transaction, and then you have the input public key address that I talk about. There's a public key address, and there's an amount. Okay, there's a transaction fee that you charge. Here, 1 minute, I move this down. Okay, and then the transaction fee, the output Bitcoins minus input Bitcoins. That is what happens, and then you can. This is the addresses. This is like your bank address. This is like the payee's bank address, right? This is the payer's bank address. This is the payee's bank address. The amounts that are there, and then the transaction. So this is what is a transaction, right? So it is something like this. You have this. These are called unspent transactions, UTXOs, right? What is a UTXO? You have 66 Bitcoins. You want to pay something. So there is the transaction number 66, transaction number 74, transaction number 32. So you had 5.5 Bitcoin, you had 0.75 Bitcoin, you had 1 Bitcoin. So totally you had 2.25 Bitcoins, right? So actually this 2.25 Bitcoin. So if you want to make a transaction, you want to send these transactions out, right? So you want to send this transaction of 1.5 Bitcoins, right? They have come from 66 and 74. So here input is 1 Bitcoin and output is 1 Bitcoin. So 1 Bitcoin is going. And from here, you have input is 0.75 Bitcoins. And then output is 0.5 Bitcoins because you are spending some amount of it. So this is 0.25 Bitcoin comes back here, right? So 0.5 is spent. So 1 and 0.5 is going from here, but 0.25 of this is coming back as an unspent output, right? So that is how the unspent transactions comes in, right? So please try to understand. We will show you what the UTXO outputs are, right? So unspent transactions are called UTXO. So I will show that amount. So please try to understand that from a previous transaction number 66, you got 1 Bitcoin. Somebody has sent it. Somebody has sent you 0.75. Somebody has sent you 0.5. So totally you had 2.25 Bitcoins. And you want to pay 1.5 Bitcoins. So you are not using this Bitcoin. You are using 1.75 Bitcoins and sending that money. So you could choose 1 and 0.5 here. You could send 1.5. But here, if you have chosen these 2 Bitcoins to send that, what you have done, you have sent 1.75 Bitcoins. So 1.75 Bitcoins, 1.5 has been sent to somebody else, and 0.25 has been returned to you. So you will be left out with 0.75 together, right? So that is how it happens, right? So that is what is how the transaction outputs is there. So if you want to spend, you create a transaction, and the transaction is sent to all the peers. This is when you are directly connected to the blockchain. If you are connected by means of a wallet, the wallet will connect you to the blockchain. And if you make a transaction, the blockchain software or the exchange software, Bitcoin exchange software, sends it to all the peers. And once the transaction is verified, it is validated and then sent to all the neighboring peers. And once the peers agree, then we will then it will be sent to all the neighboring peers, and the transaction is broadcasted to the entire P2P network. Right. So here you see that these are UTXO set. There are two databases which the Bitcoin manages. So you have the UTXO set, the file that contains all the spendable output that are available to be spent in a transaction. So this is the file which are which can be used later. So all those unspent transaction outputs, they are available in this file. Then there are mempool, all the new transactions that are being received from peer nodes which are not included in any block. They are said to be unconfirmed transactions. Unspent transactions, unconfirmed transactions. This is the difference. Maybe you can check out a little later what is there. So now, if you understand what is a blockchain, blockchain is linked by the header. Header is having the hash value and the list of transactions, right? So as we go on, so these are things which are needed: the previous block hash, the nonce, and the Merkle root, right? So once you do the cryptographic hash of the previous block, the timestamp and the transaction data, you can get the block ID. The block ID will be the header, right? So blockchain will have the previous hash, nonce, and series of transactions. This blockchain, the new block will be dependent on the previous hash value. This block will be dependent on the previous hash value, right? The chains are tied together using the previous block hash to form a blockchain. So blockchain is immutable because if you make a change in one transaction, it will affect the next hash. This will affect the next hash, and so on. So this will not allow double spending of funds. We'll come to double spending shortly. Now you may want to hear more about Merkle root. So Merkle root combines the hash values of transactions together until there is a singular root. So you construct a tree. It goes like this, and finally you get a root. That root value is said to be the Merkle root value. This is basically like a cyclic redundancy check. So you want to check the number of transactions, you want to check the amount of the transaction. Everything can be verified using the single Merkle tree root. For a big number of transactions, maybe 2,000, 3,000 transactions, all the transactions, all the amount are all summarized based on the simple Merkle tree root hash. So what it does, you can verify the transactions in a block, you can provide the immutability of transactions, because if any change is made, the Merkle root will not be hashed. So this is a simple structure, though it's a complex data structure. I'm just explaining simply. For every transaction, a hash of the transaction is maintained. So like that, two hashes are combined together, and finally a hierarchical structure comes in, and finally you get the root of the hash, which is again a hash value of. So these hashes move on. H2, H3 will result in H5, H5 and H4 will result in the root, right? So that is how a Merkle root is created. So we have seen these examples of how a block is there. So the concept of mining is basically to add a block by solving the proof of work puzzle. So it involves a lot of brute force computations. The nonce value has to be calculated. New hash has to be calculated each time, repeatedly, based on every brute force value, every nonce value, you get a new hash value, and you have to check with the target value. So this has to compare, right? So we'll see the algorithm, how it goes. So we have seen the demonstration. So the changes cannot be done because the avalanche effect in cryptographic hash is there. So one single change in a data will change in the hash of the transaction, will change in the hash of the block, will change in the hash of the next block. And hence, blockchain's immutability comes from this principle. So any change that you make, the subsequent blocks will get affected. Whenever a miner does it, so first he has to have the entire copy of the blockchain, because all the unspent transactions must be known to him. He must verify the incoming transactions, create a block, find a valid nonce, then broadcast the block. If you find the valid nonce, that means you have calculated the previous hash value, you had the new nonce you could calculate, so that the target value of the hash value is found out, right? So that diagram is shown here. So you take transactions from different people, all they are coming and falling into the mempool. That mempool, a set of transactions are taken by everybody, you bundle it into a block, then you select the header of the most recent block, and then you solve the proof of work algorithm. And when the algorithm proof is solved, it is added to the blockchain, and the blockchain continues. So this is the proof of work algorithm if you want to see it. So this is how the proof of algorithm looks like. So the slightly bigger diagram you see. So you want to propose a new block. What do you do when you want to propose a new block? You bundle a set of transactions that are sent by different users. You bundle it and put it into the block. And what you do, you create a Merkle root. So take the Merkle root, take the nonce, take the previous hash, combine them, get the new hash. check whether it is less than the target value. If it is less than the target value, the proof of work algorithm is solved, mining reward is obtained. If it is not less than the target value, you go back and change the nonce. Again, do the whole process. Come back and check it is less than the target value. No, repeat the process. So this is what the brute force mechanism which goes. You calculate and find out different hash values. So 294 million tera hashes is what you have to find out in 1 second. And once you are able to do that kind of a comparison, that powerful comparison, you will be able to solve the algorithm. If it is not, sometimes you check the values here and you get the comparison also. You get the transactions and then you could do it. So you can get the values here. So that is how you can look at that, right? So that is how this is. Then the target value also, one of the beautiful things that I see in blockchain again, something called target value. Now the target value is adjusted. How it is adjusted? It is observing. As you see the previous algorithm, here somebody is watching, right? These target values are going, proof of work is solved, mining algorithm is over. Again, propose a new block, this whole process continues. But there is another side process which is running, which is comparing how faster the blocks are getting created. If the blocks are creating faster, taking lesser time than 10 minutes, then the difficulty value is adjusted. So that's an inbuilt mechanism which is there, like how the blocks are getting created and how the difficulty value is maintained, right? The difficulty value is adjusted. The target value is maintained based on the difficulty value here. And as long as this 10-minute target is maintained, this target value, the difficulty value is not changed. But whenever this becomes easier and you see that more blocks are created in few minutes itself, in 2-3 minutes itself, a new block is getting added. The next the next blocks will take long time. So the difficulty becomes higher. So though you have the full resources, it will take maybe 30 minutes, 25 minutes, something like that. And slowly it ensures that within 2 weeks you have only 2016 blocks. That's all. So every 10 minutes on an average you get one block. So that was what. One of the work we did in MNIT was something related to mining algorithms. We had initially it was CPU, one block could be added. Slowly the power increased, so hash rate increased, so CPUs could not solve it. The people started using GPUs, graphical processing units. Then people started using fully programmable gate arrays. Then people started using ASICs. ASICs means application specific integrated circuits. And then the Bitcoin mining hardware, basically an application system, application specific IC was created. A chip was created specifically to do only the mining algorithm, right? And then it was becoming faster. So people started as this became very, of course, it needs a lot of power for that ASIC to run. And a lot of people are sharing. Miners are also not running independently. Miners have realized if we don't pool our resources together, we will not be able to solve the problem. So people are coming together and forming a pool, and they share the power, and when they get the reward, they distribute the reward accordingly, right? So these are what happens. But then people started building ASIC resistant mining algorithms. So the mining algorithm, proof of work and others were slightly modified so that even if you have a huge power or you create an ASIC for this mining algorithm, even if you create an ASIC, it will still take some set of amount of time. So they are called memory hard algorithms, right? This is an interesting. So one of my students had designed a new ASIC resistant mining algorithm. We wanted to test it on a system. Because of the pandemic, we could not do that, and we unfortunately we could not test it. But some algorithm was proposed, and theoretically we could work out, and then of course we completed, right? So hash cache and proof of stake is basically the ASIC resistant mining algorithms that you can look at. These are the websites you can look at, and RandomX also. Monero follows a RandomX mining algorithm, which is an ASIC resistant mining algorithm. And in fact, this proof of stake algorithm was rolled out in December 2020, maybe now 2 years. It is coming up, and Ethereum 2.0 is rolled out in very recent on September 6th, 2022. Right. So miners are chosen based on in the proof of work algorithm. The huge power decides the miner who will win. Who will be the fastest? He will win. In proof of stake, who has more coins in his wallet, who has more coins for a longer period of time, they will win the algorithm. So that's how the system is built in, so that it gives a bias to the miners who have more resources. So This is also because the principle is, again, it is not that whoever has the highest stake will always add a block. Then it is only one person who will add the block. But there is still a mechanism which will circulate among many people. So different people will keep on adding the blocks, and there is a mechanism by which we can say that there is a preference given to people who have more stake in the system. So that's the basic idea. Now let us start talking about some security attacks, right? So just let me give a pause for a minute. You just digest what you have heard. We are going to the second part of the talk, that is mostly on the security. We are on time. We are on time, and we'll spend the next half of the talk on different security attacks. Before we start off on security, few things that I want you to work on. Why do research in blockchain, right? There are many applications of blockchain now. Of course, maybe just let me quickly share you some of the some of the thoughts here. And so these are some thoughts I just wanted to share before I go into the security aspect. So blockchain, it's a quite old document, maybe January 2020. Now it will be 3 years in January 2023. But then it's a 50-page, 60-page document which was created by Niti Aayog on how it can be used. But a more closer strategy on blockchain was created in December 2021. Just less than 1 year. So this is something which is very recent. You can read. It's also a 50-page document. And of course, one attack surface on blockchain, there's a review paper which is about 30 pages. So you can read this. I will share some of these papers with you. Very recently, I've got this document on top 10 blockchain attacks, vulnerabilities, and weaknesses. Some of them I've included, but you can read this. It's by Cloud Security Alliance. Initially, they worked on cloud security. Now they work on IoT and also on blockchain security. So they have created a paper on this. So the Cloud Security Alliance, so top 10 blockchain attacks, vulnerabilities, and weaknesses. You can look at that, right? So why I'm sharing all this is basically because this is what will mean, because the government is very much keen. Why blockchain is not being accepted as a legal tender? Because we are not very strong in cryptography. Maybe that's what the country feels. So some of you are here. You are about 90 of you here, but you should take this as a challenge. That yes, I will try to be strong in blockchain, because you will definitely get a job also. Even if you don't do very wonderful research and get research outputs, you will get so many jobs, because many companies are focusing on blockchain as a tool. Not for cryptocurrency, but for multiple users. They are using to store data, retrieve data, and in fact, one of the challenging things is programming a blockchain. Right? I can program a blockchain. I can write codes on the blockchain. Right? So when we talk about Ethereum, you can write smart contracts. Right? The smart contracts are something that you can try to look at. Right? So there you can try to look at. Right? So there is also a government blockchain that is also being started about. So they have started the trial now in this month itself, a couple of days ago, right, on e-rupee, right? So the electronic rupee, it's a kind of a cryptocurrency that you can look at for its CBDC, right? Centralized banking distribution system, right? So you have the e-rupee that very recently. So of course there was a Lakshmi coin which was started by somebody. I don't remember, but I'm not sure what is the current market value of Lakshmi coin. But yes, Lakshmi coin also has started, right? So what am I trying to suggest is basically please try to take this field seriously. You just understood how it goes and what is happening. But then what you can try to do is use it for a variety of solutions. right? You can look at a lot of papers, a couple of international conferences that are there on blockchain 2022. Blockchain 2023 is also coming up. IEEE, you can look at that. There is ICPC, International Conference on yeah, somebody is presenting. Can you just stop sharing? Yeah, international conference on cryptography and blockchain, ICBC. So you can look at that. So these are some important conferences where different aspects are coming in. So you can try to look at that, right? So the Polygon is another blockchain that I would like to mention. Was developed by an Indian engineer. Polygon is another blockchain like Bitcoin or Ethereum or Monero. These are different blockchain names. So Polygon is another blockchain name developed by an Indian engineer, right? So you can look up Polygon and try to look at some of the data that you have, right? So I want to motivate you. So that the first half of my talk was to motivate you that cryptography is not difficult, right? It is what do you say? I can say it is difficult, but I will not say it is not impossible, right? It is possible. It is possible to work with cryptography. It takes time to understand and do that, but then you should not shy away. If we shy away from technology, we will be the losers. So that's what I want you to be hands-on onto some of these things. I will share another talk on Wednesday on the onion routing or Tor related mechanisms, right? So that also is quite challenging. We are afraid of getting into that. So very few researchers in blockchain security, very few researchers in Tor also. Tor forensics. Of course, a lot of government initiatives are there, but then yes, the challenge is for people like you. Government is looking for people who will actually give solutions, right, to the problems that are coming up in this domains, right? Let's look at. So let's continue further, and then let's look at the aspect of. We'll continue with the security attacks that are there. Yeah, so this was double spending. So double spending here is where a person called Gillen wants to spend. He has, let us say, she has 10 bitcoins, but she wants to pay to Nader also 10 bitcoins, and also to Brian, she wants to pay 10 bitcoins. And sometimes they can try to do that. If they do that, it's called a double spending attack. So this is successful only when the buyer sends the same coin to two sellers. These are two sellers. Let us say the same Bitcoin is sent to both the sellers, right? But the sellers are sending different transactions, and if these two transactions go into two different blocks, which are these two different transactions are going to two different blocks, and these blocks will get validated, right? Once the blocks get validated, only one block will get validated. Please understand that. That is how blockchain mechanism works. Just because these two transactions goes into two blocks doesn't mean both the blocks will be added. No, only one block will be added, because if one block is added, the other block will be disqualified because the transaction is verified before it is added. So it is successful if this fellow seller B sees that my transaction is added, and just looking at the transaction, if he gives the product, he sells the products or dispatches the key or dispatches a software, something like that, without waiting for the block to be confirmed, only then is the attack successful. That is what you can try to understand. So this is how it happens. So this block is added, same Bitcoin is sent to seller A, sent to seller B is adding, seller A is adding. Seller A's blockchain has been verified by 7 people, it is accepted. But then the others don't accept this, they don't confirm this. Why they don't confirm this? Because this transaction is already confirmed here. If this transaction is confirmed here, in this transaction, this will be not confirmed. If this is not confirmed, it will be safe. So buyer succeeds in double spending only if his confirmed transaction is sent to seller A. It is rejected transaction to seller B, but seller B has already sent the services. Hence, he receives the services, the seller B loses. So that is how when the double spending attack is successful. There's another concept called 51% attack. Now, just imagine 10 people are very powerful miners or miner pools which are fighting to add one block. So let us say in these 10 people, 6 of them are friends. Right? So what happens? All the 6 will tie up and make a transaction and add a block, and 5 of them will verify. So it becomes a block. So if I can get, or if I can try to influence the blockchain mechanism or I get the power which is more than 50%. So 51% means more than half of the power. So once I have more than half of the power, I can control the blockchain. This may happen, and one of the strong contender is the what is that? Is the quantum. So once quantum comes, you can easily get more power. Of course, by that time, quantum resistant mining algorithms will come in, right? Of course, the blockchain will try to survive all these changes. But then, yeah, you need to understand. So my interest also goes into quantum, as some of you would have heard. So when I try to build a quantum algorithms later, so obviously I will be building quantum resistant mining algorithms, right? Because I will know the power of quantum, and then I will know the power of blockchain. By the time, blockchain will have become even a bigger market, and we need to continue to keep the blockchain alive. So we need to develop quantum resistant mining algorithms. So this is how we are somewhere left. When I was first exposed to this blockchain and I started talking about blockchain, I did not know much. But today, when I see this, and today also, after speaking for blockchain for so many times, now I see there are so many changes that have happened, and it is amazing how things and how people are using, and we are left behind. And I don't know how much you are able to grasp and understand what I'm saying, but we can't neglect it. And if you're looking for a research aspect where I want to start off, this is one very good area, right? So please look at, right? So you can prevent transactions and blocks from being verified, reverse the transactions, make a lot of changes, because you are having more than half of the control, right? So that's another attack. This is a security attack which may be possible, which can happen when centralization of mining pools which acquire more than 50% of the hash power, then it is able to do that, right? And just understand, for Bitcoin, the hash power is more. But you go to the smaller Bitcoins, smaller coins, the power is not much. So if you are a Bitcoin miner and you come back to a smaller mining, so you have more power. You can easily do some of these 51% attacks, right? And then it was possible. Ethereum suffered a Bitcoin, this thing 51% attack, and it was forked also. It became Ethereum Classic and Ethereum. So two different blockchain started. The split, the Ethereum Classic split from Ethereum, and then you could do that, right? So if you're having 2 billion market cap, you need $1.5 million power to execute a 51% attack. So these are things which you can try to look at, right? So this is what is an example as you look at what is the nice hashable, the computation power available to rent on a website called nice hash. So you can try to get this thing, and then you can also, if you want to try to attack, what is the cost that you will try to do. So you can pay that, and then you can get the power, and then you can do that. So you just see, attack tools are sold online, right? So that's what this 51% attack talks about, right? Ethereum hard fork, it had hard fork many times, and it had the attack 3 times in August 2020. And once you see an attack, a lot of blocks are left unattended. So many blocks are created, but that series, the smaller links are dumped. So all the transactions that are added, all the things that are added are lost, right? So those things that we try to look at, right? So blockchain Dash, this is another blockchain Dash, the one with the D with a line in between, that's a Dash, right? So that's the Dash blockchain. It uses a secondary validation layer called the chain locks, right? So it makes block reorganization, it makes it expensive for the attacker, because it has another validation layer apart from the this thing. Of course, people have different thoughts. Just understand this selfish mining algorithm. Selfish mining, what happens is, just understand this gentleman here. He has got block 1, block 1, block 2, and 1 block n has been created. This fellow has done block n plus 1 very fast. But he doesn't add to the block. What he does, he creates block n plus 2. He doesn't add both these to the block. He creates block n plus 3. Meanwhile, the others are struggling, and they have created block n plus 1. By the time he adds block n plus 1, this fellow has created block n plus 3. And suddenly, once this block n plus 1 has been added, he adds these 3 blocks in one single time. This adds immediately, and immediately after that, one more. Immediately after 1 minute, one more is added. So all 3 are added. So what happens? So you by the time this fellow, this is a honest this fellow, and this is a selfish miner. So what happens? This becomes an invalid block because this block has extended already. Right? So these 3 blocks will be awarded. So all the 6.25, 6.25, 6.5, 20 bitcoins this fellow gets immediately, and he loses the 6 bitcoins. This fellow is the honest miner. Of course, he's the one who got this first. He doesn't announce. He knows that he thinks that this will take some more time for the other. So let me calculate the next block. Let me calculate the next block, and he does that, right? So efforts put by honest miners is put to loss, right? So we lose that, they lose the amount, right? So that is the attack. There are distributed denial of service attacks. Distributed denial of service, you would have heard. Different people are trying to attack. So usually they are attacking the software, they are attacking the hash, they are attacking, the wallet, they are attacking the software. So usually the miners who are actually trying to run and use the resources, their what happens is they take them out of the network, and increasingly the malicious miners' effective hash rate is lost. So the honest miners waste their time in verifying fake transactions, reducing their chance of mining a block. So what happens? A lot of false transactions or fake transactions are added to the network, which are not there or which are already added, right? So those people are working on those transactions, adding them, and you are mining, and those blocks are going to be invalid after some time, right? So that is something that you can look at. So network attacks that you can look at. This is an example that you can look at the steps. You will understand. This is the DNS entries here. The DNS server is there. So the DNS server, what this fellow has done, attacker has poisoned the DNS. DNS poisoning attack. You can look up other security lectures. You can get that. So DNS poisoning is an important attack. So this fellow has created a DNS poisoning attack, and now the user wants to reach out to the blockchain network. The user wants to reach out to the blockchain network. So what happens is when you want to reach, instead of giving this address, it is directing to a different address. It is different. They are sending to a attacker network. You are wanting to join a blockchain network, which is the legitimate one. You actually send to some attacker. This fellow attacker has created a network of his own. So instead of coming here like this, you are going like this. You are going to another this thing. So this is something that you can try to look at, right? So this is the attacker's network, right? So this is what exactly happens. So and then there are of course some attacks like Eclipse attack, where a group of malicious nodes isolate the neighboring nodes, compromise their incoming and outgoing traffic. So they change the blockchain view of the honest nodes. So the white nodes are the honest nodes, and the red nodes are the malicious nodes. So slowly these red nodes will keep giving wrong information, and they also will become malicious nodes. So finally, all the nodes will become the malicious nodes. So feed them fake information regarding the blockchain transaction. So once we give wrong information here, this also becomes malicious node. Slowly, all the nodes will become malicious, right? The malicious node then send fake transactions and blocks to these nodes, and that's how the Eclipse attack continues. There are privacy attacks as we look at. So usually blockchain network, I told you in the beginning that the address cannot be identified. So this address, when you look at it, you don't know whose address it belongs to. You cannot get any information from that, right? So you can create a QR code also. Nobody will be able to do anything. People will know the value, people will know the code, people will get the values, but the individual behind that, who created that address or what is the balance amount, cannot be understood, right? So each user is identified by its address only and can generate as many addresses as required based on his private key. And private key is like your password, you won't tell anybody, right? So as long as your private key and public key are, public key is anyway known public, private key as long as it is private, like it's like username everybody knows, right? But like your email ID, if somebody has to send an email, he has to know your public key, that is your email ID. But password is what you will open and see the, that's called a private key. As long as the private key is with you, so there is no issue. So and then using the private key, you can create as many addresses as you want. But then there is a privacy attack. What has happened? As blockchain is replicated at each node, observer can use the transaction history in blockchain. They can find out topology of the network, the patterns of the transactions, and the patterns of the user's transactions. See, many times we may not know what the transaction happened, but two people, there was a transaction which happened between two people is also an information. Like let us say some politician calls up another politician in another country, or the head of state calls up another head of state, right? What they talked may not be available to anybody, but they talked is also some information, right? So that's something which is a kind of a privacy attack that we're talking here, right? So based on that, somebody has created a trying to find out how many global Bitcoin nodes are there. They found out the distribution. They found out that in India few Bitcoin nodes are there. Many are there in Europe, many are there in US, many are there in Singapore and near Taiwan and those places, Hong Kong and a lot of much part of China. There are a lot of nodes which are there, and according to the country, they could come and try to identify. Yeah, you just understand without knowing anything, right? But obviously, when you are connecting to a network, which is a peer-to-peer network, which is running worldwide, you can definitely get some information about the network that you are connecting to, right? So that's how this privacy attack would happen, right? So here, another this thing, the transaction network can be developed to study the flow of bitcoins. This bitcoin is going and this is distributed like this. So usually, the unspent transactions we discussed, right? So some part of it is coming back to your network. The user network can be developed to study the ownership and spending patterns of users. Now, when that whole big chain is there, though you don't know who the individual is, you can take a particular address and track to that address through all the people, right? All the addresses. That's a kind of analysis that you can do. So here, using the transaction patterns, you can attempt to de-anonymize the users. You can find out their addresses. They can find out the real world entity. You may not know exactly the individual's name, but you can make it pseudo anonymous, right? The transaction network analysis is an example. Payment to a vendor whose address is scrapped off the network. So vendor's addresses usually is known, and then somebody is making transactions to that vendor. So we know that this individual is buying some things like this, right? So that's a kind of a privacy attack that is there. Sometimes many addresses are shown here, and they are making a transaction to a single address. What does it mean? This gentleman, 5 gentlemen or 5 ladies and gentlemen are sending to this person. But usually, it all may mean that these 5 addresses are belonging to the same one source. It may be one individual with 5 addresses which are generated using the private key, right? So that's how you can write. So you know that all these 5 addresses are belonging to the same individual. Then you can make a lot of transaction changes, right? So that's how you can do the tracking. You can also look at this. You have the change address usually that is used. So there's 4 bitcoins. You want to pay somebody. This is one transaction. By each transaction, you got these 4 bitcoins, right? These 4 bitcoins now you have. Now these 4 bitcoins, but you want to pay somebody only 1 bitcoin. If you want to say 4, if you want to spend 4 bitcoins, you send this address to somebody else, no problem. But if you want to spend only 1 bitcoin, so 1 bitcoin is sent to the recipient's address. 3 bitcoins will come back to you. But here you will use a change address. So whenever people see these transactions, they know that okay, this is going to the user. Somebody else, this is going back to the person. Here 3 bitcoins, again the 1 bitcoin is going somewhere, another 2 bitcoins are coming back to the address. So this change address and this address, these 3 are belong to the same individual. So based on these addresses, you are able to construct some information. So this is another privacy attack that you can look at. A lot of illegal activities happen, and I wanted to discuss about the Silk Road also. Silk Road was there, which was used for money laundering and also buying some illicit activities on the deep web. Another important aspect that we're going to talk about on deep web and dark web, right? So we will discuss on Wednesday. So the onion routing that we use, the browsers that we use, and the attacks that are happening, and how we can try to analyze these anonymous networks like Tor. What can we do? Torrent is based on Tor. We look at that. So if you combine blockchain and Tor, it becomes even more dangerous, right? So that's something that you can look at, right? It's already a lot of things are anonymous, and if you add more anonymity to it, it will become even more difficult, right? So there are a lot of people can have scam activities like tricking people into sending bitcoins, because there's nobody who will verify those transactions, nobody to refund those transactions or revert those transactions. It becomes very difficult. That is something that you cannot do. A lot of times people can steal your keys because you are, if you have a wallet and you're storing the keys in the wallet, somebody can hack your wallet and steal your keys. And if they have the keys, it is like having a password to your internet bank account. They can transfer money, they can make transactions on your behalf. So wallet file is stored unencrypted by default, so it's all the more difficult. Malware attacks can also lead to malware. The wallet theft attack, right? So if you are using a host to do your transactions online or exchange on your online browser, so malware attack can actually get those wallet IDs back to anybody else, right? So adversary can steal the file and they can sign the transactions. It's like you're getting your internet banking password and the transaction password. If you know them, you can make transaction on anybody. So something like that. The public key and private key of the blockchain, once it is stolen from your wallet, you can do that, right? So the cryptography exchange, currency exchange also, it's like a stock market of cryptocurrencies. So this is the centralized exchange that we're talking about. Of course, this is not an attack. This is the concept that I'm talking about, so that we can also try to understand the reasons why we need to program blockchains. The blockchain program is quite complex, so you don't worry about it. Elliptic cryptography and so many hashing and so many mechanisms are used. But if you look at it, we can try to look at what is called the programming part of the exchange, right? Programming part, not the exchange, programming part of the blockchain. So when you build an application on top of blockchain, a lot of websites are built which will give you the data about the blockchain. That is one part. But then you can program the blockchain. So some of the transactions can be made conditional, right? So Ethereum offers a tool called offers a mechanism called smart contracts, which you can write in a programming language called Solidity or Viper. I think I'll share it a little later. But then here we're trying to look at this cryptocurrency exchange is an application which is sitting on top of that, right? So buyers and sellers have to trust the middlemen maintaining the centralized exchange, like Binance, Poloniex, Bittrex, Gemini, Wazirex. So variety of these things are there. They have become. So what you're actually trying to do is you're entrusting your private and public keys with them, right? So you can buy, sell, and trade with a lot of cryptocurrencies, right? So that is how the centralized exchange is there. The decentralized exchanges are also there, where funds are controlled by the users themselves. They operate by means of smart contracts. No middlemen are there. So these are applications which help you to create your own, exchange mechanism: Uniswap, 1inch, and SushiSwap, right? So there are attacks on cryptocurrency exchanges also. So what happens due to cloud security and social engineering, but specifically not on blockchain, but on the applications running on top of it, right? So the phishing user credentials to gain access to cryptocurrency accounts, or maybe SQL injection or software vulnerability of unpatched software. Sometimes Mt. Gox, the first exchange which was there, when it used incorrect wallets, lost 850,000 bitcoins. After that, Mt. Gox got closed, right? So that's how some of these attacks could be there, right? So there are different scams which are there called rug pull and exit. So then exit scam, which is an exchange disappears with user fund. So they create an exchange, and a lot of it becomes very popular. It's like PhonePe or some of these things. Now, PhonePe and Google Pay, you depend because you trust Google, and hence you trust Google Pay. But what exactly happens is when you are having, someday Google Pay takes your money and you store some of the money on the Google Pay wallet, and Google Pay wallet takes the money and goes away, right? Because now you don't store it in a wallet. You only use the wallets for making transactions. Earlier, people used to put money in Paytm, because when they were not, it was not, some of the people did not have the bank accounts linked to it, so you could not send from bank to bank. It would go from bank, Paytm wallet to Paytm wallet. So you used to put money in the Paytm wallet, right? Now you don't do that, right? So now it is there in the bank. Your bank account is safe. Paytm only has a handle to it, right? But here also is a similar case where you try to deposit your money or give your private key and public key to the exchange, and the exchange handles the money for you, and suddenly one day they close the software and go away. You can't catch them, right? So it's because of the centralized nature of the exchanges. Rug pull is basically involves pulling the rug out from under users by selling majority of the DeFi pool, thereby draining liquidity from a specific token. So DeFi project, the finance, Composer.finance, so the company. So a hidden backdoor written into the smart contract allowed developers to pull $10.8 million from the project's liquidity pools. So the money is actually there, but then the smart contract loopholes allows, you write a backdoor which deducts money. Smart contract. We will see some more attacks like that, where re-entrancy attacks and problems in the coding of the smart contracts, like Solidity and bugs in Solidity, and some of the bugs that you create when you're developing the software can create this thing, right? There are other attacks like phishing, where you can send a phishing email to update valid seed phrase using the provided link. So it's like sharing your password. We are doing a maintenance, and you please share the password, so we will do the update, needed update. A lot of people share their internet banking passwords to people who ask for that, right? So that's a big issue. So phishing attacks are there. Recently, one of my friend also saw a Facebook message of mine. Somebody called me, or somebody chatted with him on the Facebook chat, and he thought it was because he was using my photograph and my handle, my title looking similar, right? He did not call me before he made the transaction. He sent some money to that individual, right? So those are phishing attempts, right? They are not real attacks, but they are made to work on human emotions, right? So they may have felt my cousin is needy, something like that, right? So the ransomware is another malware which blocks access to a computer or network until the ransom is paid. So WannaCry and Colonial Pipeline, a lot of attacks. Recently, we have experienced similar attacks in some of systems of our faculty members, right? So SwimSwap is another attack. Use of stolen phone numbers to access accounts on cryptography exchanges is another big issue. So whenever your phone is lost, please ensure that the SWIM is blocked and the SIM is not issued to somebody else, because the cryptographic currency exchanges can be, again, like anybody who gets your bank account. If you have not changed the bank account number, phone account number in your internet banking, this thing. So anybody who opens the phone and installs the new, let us say ICICI bank account you had, and your phone is lost and you lost the SIM, you have not made the change in the bank account. Somebody else has purchased the same SIM with your number, and you have used the same, he has used the same number, and he has installed ICICI. Immediately your bank account will get linked, right? And then if he's quite intelligent enough, he can actually get hold of your money, because he needs to only guess your transaction password, right? So on trial and error, you can try to do that, right? Investment scams also there. So these are some issues that you can look at, right? So then there are high profiler doubler scams, right? So this is something like some messages which are given from very popular high profile individual, right? So then people are sending Bitcoin. So if you please send the Bitcoin, I will send back this thing, right? So just imagine, right? Everybody is asking to give back, and I'm giving now. So anybody who sends me $1,000, I will send back $2,000. So all the $1,000 are corrected. So these are using Bitcoin transactions. People are trying to do that, right? Similarly, attack vendors. So there's an attack surfaces. So this is from that paper on blockchain attack surfaces. So you can look at variety of attacks that are happening: attacks on blockchain structure, attack on the peer-to-peer system, attack on the blockchain applications. So you can go through that paper and look at different attacks at different levels. You can look into that, right? Solutions for that is, again, the next level blockchain 2.0 is suggested, where you can try to look at handling variety of things. To handle blockchain 2.0 in Ethereum, they have come up with this smart facility called smart contract. Smart contract, as I was mentioning, it's a code that facilitates, verifies, and enforces the negotiation or execution of a digital contract. So the transaction can be looked at as a digital contract. So if that has to be executed, right? So there's a code which has to be executed. The code should run. The code verifies that the transaction can proceed, right? So that is something which is possible, right? So Ethereum is one decentralized platforms which can run smart contracts. So smart contracts in Ethereum react to external world when they are poked by transactions. So the Solidity and Viper, as I mentioned. So Solidity is a very popular language. If you want to program a blockchain, so you can learn Solidity, and you can program Ethereum, and you can write smart contracts. So this is the second level. First level is to understand how the blockchain works. Second level, set up either Bitcoin Core or Ethereum. These are permissionless blockchains. You can set up private blockchains, which you can do it on your own. It's like setting up private cloud, right? Public clouds are there, private clouds are there. Similarly, public blockchains and private blockchains. This is the Solidity documentation. You can go and look into the website. There's an editor, like you have the Eclipse editor or the Jupyter Notebooks. You have the Remix, which is an editor for Solidity. You can also use Visual Store to be a code. A sample example, this is how it looks like. The Solidity code looks like that. So you have various functions, and then you can use that. So this is how a blockchain code looks like. But there are some problems in the code also. So the code is written in smart contract it may not be secure. It can lead to some attacks. One of the attacks that was observed was a re-entrancy attack. It was observed in 2016. It happened in what was called a DAO hack, or DAO stands for Decentralized Autonomous Organization, which was intended to act as an automated company, which was kind of a mediator company. But then these recursive calls, what it does happen is, so the DAO was attacked and 60 million Ether value was stolen, right? So the DAO had to be shut down, right? So what happened was, there was a contract called DAO vulnerability. So what happened was, there was a function called withdraw balance. So the withdraw balance was, each time it was called multiple times to empty the attack account, as the account balance is reduced after this call. So actually, this call is actually going for only one withdraw option. But this re-entry attack, what it made, it made this withdraw balance attack to be called multiple times. So instead of drawing $100, you could draw $100 10 times. So the transaction was for $100, but transaction was made for $1,000. So a lot of people lost money like that, right? So the contract got exploiting DAO vulnerability, withdraw balance calls itself again and again. So this is the withdrawal function. So that is there. So that is how it is. So the code is written as smart contract is not secure. It may lead to other attacks also called the overflow attack, right? So Ethereum smart contracts don't support values greater than 2 power 256. So there's a buffer overflow attacks which can be created by having a really large value. Forcible balance transfer can be done if the contract is vulnerable. Forcible balance transfer can be done and limits can be exceeded. The DOS smart contract can be written with malicious intent causing denial of service. So that was that. So smart contract could be written. This was the thing. Of course, the one solution as we look at for these privacy attacks, as we looked at, is a complete new blockchain which was written to preserve the privacy. It's called Monero. So Monero uses different mechanisms which adds cryptocurrency and uses privacy using different mechanisms called stealth addresses or ring signatures and also confidential transactions. So these three mechanisms as we look at. Of course, I know that you're all slowly trying to already too much of content has been delivered. I understand that, but then that's how the world is now. If you don't wake up, we are late. So we already discussed so many names, right? In fact, I have not talked about Hyperledger. Hyperledger is a very easy blockchain that you can start setting up with. Ethereum and Hyperledger are very easy. Monero is one which you can try to test. So these are in Bitcoin Core. And then some of the codes that are there, Solidity codes, and also on Bitcoin, if you want to program Bitcoin, you can use the Bitcoin Core. It's called the script. The language itself is called the script only. So you have HTLC scripts and you have P2SH scripts and different scripts. I'll show some of them. Maybe I may not have time to share all of them, but then yeah, let's first understand Monero. Monero's stealth addresses. So what is actually happening is there are two addresses. They're making the transaction to the same individual. There's a linkage that is getting created that these two individuals are linked to this Charlie. But then what Monero helps is it creates an unlinkability. So Alice will send to same Charlie and Bob will also send to same Charlie, but these two addresses will be marked different, but they will be unlinkable. So we are using different addresses in each transaction, which is possible. So the unlinkability is facilitated, right? So the different destination address for each output is derived from one Monero address. So only the owner of the Monero address knows the output is from him, right? So nobody can tell these outputs are going to the same person. Traceability, some transaction ABC is coming to some addresses and they are coming to some addresses and they are coming finally to Charlie's address. So you are able to trace that these transactions are finally reaching Charlie's address. But then here, if these addresses are different and they're all coming from here, so you know that transaction 1 is pending funds received from these transactions. But transaction 1, where it is getting funds is not traceable because these addresses are all different. So we don't know. So there's no idea which funds are spent on transaction 1. So some addresses have come and they are coming to this transaction 1. So we don't know the linkage of these funds. This transaction fund, where it is coming from, we don't understand. That is called untraceability. The other one is called ring signature. Ring signature is where you are using what are called mix-ins. Mix-ins are outputs from some previous transactions. Those transactions are already being used, but then you try to create a ring signature, only one signature out of the ring is a valid signature. So what do you say? You find some outputs in the blockchain with the same amount X as the output A you want to spend. You want to spend, let us say, $100. See transactions which have already been spent, which are $100 in nature. So you bring all those transactions and add them as mix-ins. All the mix-ins will have same value, that is $100. You can use up to 4 to 25 transactions in a mix-ins in one transaction. You can sign the transaction using a ring signature. What is a ring signature? You will sign here. So these are, some of them will be mix-in, some of them will be a genuine transaction. One genuine transaction, the remaining are mix-in. So these transactions are coming and these are going. So out of these, again, one transaction is valid and the other transactions are not valid, right? So one user from inputs have signed this ring transaction, and it is not easy to find which user has signed the transaction, something like this. So if you want to send X Bitcoins, you find out you find at least 3 transactions. One is your transaction, you will add 4 transactions. All these 4 transactions are sending X Bitcoins. Finally, somebody is receiving X Bitcoins. Let us say some Bob's address is receiving X output. But who sent? Whether it was whether he or 1, 2, or 3 or 4, who sent the transaction is not available, and hence this ring signature is not valid, right? Now, at least sometimes this address and the transaction amount is valid. So we know that this address is sending this much amount. We are able to come to some conclusions, right? So when you don't want that, so when you want to provide confidentiality, so they use what is called a bulletproof technology. Now, what is a bulletproof technology? They are called short non-interactive zero knowledge proofs, NIZK, non-interactive zero knowledge proofs. These proofs are used to create confidential transactions to prove that the encrypted input and output of transactions are in a given range without revealing any information about the numbers. What address is coming from, what is the amount that it is coming, we don't know, right? So here they use what is called the Pedersen commitment. So you want to pass some value here, so we don't know what are the values here. Some values are passed here, we don't know what the values are. Input and output amounts are replaced by cryptographic commitments. So the commitment is built on X and R values. So G power X, H power R is what is only seen. So when looking at those values, you don't understand how much is being sent and how much is being received. So that is how they are making this thing. So transaction amounts are hidden. Transaction graph is still public. Public can verify all the transaction validity. All these things are possible, but the amounts are hidden, right? So what happens is you have this use this principle called non-interactive zero knowledge proofs, and then you can do that, right? So usually the Pedersen commitment C is called G power X, H power R. X is the value that has to be obfuscated. You want to hide the value X. X is the transaction amount. R is any random number. G and H are using electrical cryptography. You are able to get the distinct generators. So you get a value G power X, H power R, which will be C. The C will be shared. So the other person who is receiving the value of C, okay, he is able to understand the value of X. So it is binding that the prover cannot later come to another Rx that gets to C. It is hiding such that it is difficult to guess X from C, as there is another factor H. So by looking at this, you cannot get the value X. Looking at C, you can never get the value of X. And using X and R and G and H, you can calculate the value of C, which can be shared publicly. So these are some things, and of course, they are called homomorphic cryptographic commitments, and very difficult to verify. So you can read through that when the transaction, when you get the slides. So these range proofs are also there, which are called zero knowledge proofs. There's a huge content which is there on zero knowledge proofs. I leave it for you to go through. I will give you some time for asking me questions. So we'll stop here, and if there are any questions, I'll be very happy to answer. Yeah.
Thank you, sir. Thank you for the very knowledgeable session. Dear participants, if you have any question regarding the session, you can ask. I think, sir, there is no question. Thank you, everyone.
Yeah, I'll share the slides to Dr. KP Sharma, and he will share the
Okay, sir. Thank you. Okay, dear participants, the next session will be at 10:30 a.m. tomorrow at the same Google Meet link. You can also attend the previous sessions on the YouTube at NITG official channel. At the end, once again, thank you all and see you tomorrow for the next session. Thank you.